Day 489 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3516. Find the closest person. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. And don't forget to hype too. So now let's see what the question says. You are given three integers x, y, and z representing the positions of three people on a number line. X is the position of person number one, y is the position of person number two, and z is the position of person number three who does not move. Both person one and person two move towards person three at the same speed. Determine which person reaches person three first. Return one if person one arrives first. Return two if person two arrives first. And return 0 if they both arrive at the same time. Return the result accordingly. All right, y'all, so that sounds simple enough, but let's take a look at these examples anyway, just to make sure that we understand this problem correctly. So in example 1, we have our input x equals 2, y equals 7, and z equals 4. Our output is 1. Explanation says the person 1 is at position 2 and can reach person 3 at position 4 in 2 steps. Person 2 is at position 7 and can reach person 3 in 3 steps. Since person 1 reaches person 3 first, the output is 1. All right, y'all, so let's break that down one step further. All we want to do is see which person is closer to z, x, or y, right? Whichever is closer to z, that's the person that's going to win. So in this case, x is person 1, y is person 2, z is person 3. As we can see that z is 3 positions away from y, right? Because say we could just if we subtract say we subtract 4 from 7, that's going to give us 3. But we're actually going to be working with the absolute value. So let's do it like this. Say we subtract 7 from 4. Say we subtract 7 from 4, that's going to give us -3. The absolute value of that is 3. That means that person 2 is 3 steps away from person 2 is 3 steps away from person 3. Then we have x equals 2, so we subtract 2 from 4. That's going to give us 2, which means x is 2 positions away from person 3, right? So person 1 is 2 positions away from person 3, and person 2 is 3 positions away from person 3. So since person 1 is closer to person 3 than person 2, then we're going to return person 1 because it's the closest and it can get to person 3 fastest, right? So all we're really doing is getting the absolute value of z minus y or z minus x, and we're seeing which one is smaller. So let's take a look at example 2. In example 2, we have our input x equals 2, y equals 5, z equals 6. This time the output is 2. Explanation says person 1 is at position 2 and can reach person 3 at position 6 in 4 steps. Person 2 is at position 5 and can reach person 3 in 1 step. Since person 2 reaches person 3 first, the output is 2. So similarly in this problem, right, we have person 2 is and person 3, they're 1 step away from each other, because if we subtract 5 from 6, that's going to give us 1. If we subtract 2 from 6, that's going to give us 4. Since 1 is less than 4, we're going to return person 2 because person 2 is closer to person 3, so they'll get there first. So let's take a look at example 3, where they might try to throw a trick question our way where they're both the equal distance from each other. So in this case, input x equals 1, y equals 5, and z equals 3. The output is 0. Explanation says person 1 is at position 1 and can reach person 3 at position 3 in 2 steps. And similarly, person 2 is at position 5 and can reach person 3 in 2 steps. Since both person 1 and person 2 reach person 3 at the same time, the output is 0. So in this case, we have we subtract 3 from 5, that's going to give us 2. Say we subtract 1 from 3, that's going to give us 2. Or since we're working from absolute values, let me put it like this. Say we subtract 5 from 3, that's going to give us a -2. The absolute value of that is 2. Then say we subtract 1 from, say we subtract 1 from 3, that's going to give us an absolute value of 2 as well. And since they both are equal to 2 steps away, our output is 0. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Hopefully, if you don't understand the question so far, which you should, the solution will make it make sense even more. So let's get into it. Now, once again, we're going to be dealing with absolute values because say we have something like this and we subtract or say we subtract 7 from 4, that's going to give us a -3, and that if we don't use the absolute value, -3 would be less than if we subtract 2 from 4, which will give us 2. -3 is less than 2, so that would give us the wrong answer. That's why we want absolute value, so it can be 2 and 3 instead of 2 and -3. So let's get into the problem so I can show y'all. So first thing we're going to do is we're going to compare the absolute difference between z and x and z and y. So we're going to say if ABS, open up the parentheses, z minus x, come outside of that, is less than ABS, open up the parentheses, z minus y, then we are going to open up the brackets and we are going to return 1. Now let's go through this, right? So let's come down here. Say we have z, and looking at example 1, say we have z equals 4, boom, then we have x equals 2, sorry y'all, and then we have y equals 7. So let's go through this. Boom. So absolute value z minus x would be 4 minus 2. So we have 4 minus 2. We want the absolute value of 4 minus 2. And we're checking to see if that is less than the absolute value of 4 minus 7. Now this is why absolute values are important, because this is going to check to see we want the absolute value. So this normally will give us 3, but -3, but the absolute value is going to be just 3. So this would be 2. We're checking to see if 2 is less than 3. So if 2 is less than 3, that means that x, or person 1, is closer. So that means x is close. That means this person is only 2 steps away and this person is 3 steps away. Now, if we have to do absolute values, because say if this was -3, then all of a sudden this is not true. Right now, all of a sudden -3 is not greater than 2, so that wouldn't return true. That would return false. Whereas this case, now it returns true when we get the absolute value, which is just the absolute value is just how far away is the integer from 0. So -3 is 3 away from 0. So that's why it's 3 right here. And now this is true. Now 2 is less than 3, so we can return 1. Boom. So that's just how that works. Just want to show y'all. So now we're going to say, come up here, we're going to say, we're going to handle the case where they may be equal. So we'll say else if the absolute value of, open up the parentheses, z minus x is equal sign to the absolute value of z minus y, meaning they're the same distance from each other, then we could return 0. Right? Because if they're the same distance from each other, that means they'll get there at the same time, and so we could just return 0. And then else we could just handle, that means that this is that just means that they're not equal, and z minus x is not less than z minus y. Then we could return 2. Boom. And that's all she wrote, y'all. So let's give it a run. Make sure it runs correctly before we submit it, and it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it, And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see. So once again, we're just trying to see which person is closest to the third person, and whichever person is closer, that's the person we're going to return. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.